We're now starting on chapter 1.2, which is using segments and congruence. We're going to look at vocabulary. The first vocabulary word is postulate or axiom. This is a rule that is accepted without proof. What that means is, for example, if you were playing a game, you would have certain ground rules as far as taking turns and things like that. And a postulate is sort of like things we just accept. We just say, that's got to be the way things are. So, first of all, the rule or postulate. It says points on a line can be matched one-to-one with the real numbers. The real number corresponds to a point that is called the coordinate. So, for example, if we had points A and B, and we wanted to know the distance between them, first of all, we would write this as AB with no bar above it, and that would be the absolute value of the distance between the coordinates of A and B. I'll show you an example of that right now. So let's see, I gotta find this real quick. Whoops. Go here, and I'm gonna pull out this number line right here. Close this. So we have a number line here. And let's say we call this point, we'll call this point A. And we'll call this point B. And we want to know what AB is equal to. So we use AB with no bar above it, and we say it's the absolute value of those two numbers. So in this case, it would be -5 minus a -2. If we go further with that, we'd say it's -5 plus 2, because remember when we subtract a negative, it's the same as adding. That would give us the absolute value of -3, and the distance then would be 3. Of course, we always can use the counting method and just go 1, 2, 3. That would work as well. Okay? More vocabulary, not as much as last time, so we're in good shape. Coordinate is the real number that corresponds to a point on the line. So when we talk about a number line, if we talk about point A on the number line, that was -5, and point B was -2 in the last example I just showed you, if you want to take a look at that. Point A was -5, that was the coordinate. Point B was -2, that was the coordinate of that one. Distance, this is the absolute value of the distance difference between 2 points. We just showed that on the last example. It's also called the length. So when you hear distance and you hear length, basically the same thing. Between, when we have 3 points on a line, you can say that one point is between the two. We talked about this in the last section. If I was to draw a line, here's my line, and I draw some points on that line. And let's call this A, this is B, and if I put this anywhere in between the two, I can say C is between A and B. Okay? Last section, we've got another postulate here. Remember, that's something we just accept without having to prove it or anything. So we're going to look at a segment addition postulate, and then we're also going to look at congruent segments and what that means. If I draw a line segment, so I'm going to make this a segment. If I draw a segment like this, and I put A here, I put B here. Oh, no. I put B, sorry, here. And I put C here. What I can do is I can say AB, which is this distance right here. So AB plus this distance right here from B to C is equal to the whole length, which is AC. Okay, where B is between the two. We can also use this in another way where if we know the whole length and we know this length, for example, let's say this is 3 and the whole length is 8. So then what I can do is I can go, oh, okay, this is 8 and that's 3, so to find this I would have to subtract these two. Whereas if I knew that this was 3 and this was 5, then this would have to be 8. So in this case I would say 3 plus 5 equals 8. And if I was given this right here, I would say 3 plus BC equals 8, and I would have to subtract 3 from both sides. And I would get BC equals 5. Okay? The last thing, congruent segments. These are line segments that have the same length. So if I draw a segment like this, and let's say I take this and I'm going to use the old copy and paste. We can take a look at these, and these both have the same length, therefore they're congruent segments. The symbol for congruent, let's say I call this A, this B, this C, and this D. The first thing I'd have to do is I would have to say that AB with a segment above it, and then we'd use this symbol for congruence, and we'd write CD. Okay? But we also know they have the same length. So if they have the same length, another thing we can do is we can write AB is equal to CD. These are basically equivalent statements. It's a little confusing. What this is saying is the two lengths are the same. This is saying they're basically the same segment. Everything about them is the same. Okay? This we use with equations. This we don't use with equations. Now we're on to the examples. Here we have a segment of length that we want to measure the length of segment ST to the nearest tenth of a centimeter. I'm just going to show you this example. I'm not going to write on the board for it. So basically what we would do is we would take a centimeter ruler or any kind of ruler and we would measure this out. Okay? Now what we can do is most of the time what we do is we line it up with a 0, but we could line it up with a 2. So S is at 2 and T looks like it's close to 5.4. So now we can measure that length, or we can subtract those two using the ruler postulate. We do absolute value of 5.4 minus 2, and that gives me 3.4. Okay? Alright, this is similar to the example I showed you with the segment addition postulate. Okay? We've got these three cities that all line up in a line. We've got Lubbock, Tulsa, and St. Louis. And we want to know what is the distance from Lubbock, Texas to St. Louis. The best way to do this is to say LT is the segment, and if we add that to TS, it's going to equal the whole length, which is, whoops, sorry, not T, but LS. Now we know that LT is equal to 380. We know that TS is equal to 360. And this is LS because we don't know it. So our final answer here, if we add these quickly, we've got 0 here, 14, carry the 1. We would say this distance is 740 miles. Okay? Alright. It says to use the segment addition postulate to find xz. This should be pretty easy. X is here. XY is equal to 23. YZ is equal to 50. So we know that XY plus YZ is equal to XZ. Therefore, 23 plus 50 is equal to xz, and xz is equal to 73. I hope this is getting across to you pretty well. I think this isn't too difficult of a concept. All right. It says wy is equal to 30. So I'm going to write that in here. So we want, whoops, let's see if I can do that. Oh, that's right. I got to use a different color, sorry. So this is 30, okay? Can we use the segment addition postulate to find the distance between w and z? Well, not really. If we were to go around it, we would say, oh, okay, from here to here it's 30, from here to here it's 50, but that doesn't make this equal to 50 plus 30. So since we don't know what this distance is from here to here, we can't use the segment addition postulate. We can only use it when they're all on the same line. Okay, here's another segment addition postulate problem. Here we see we have FG plus GH is equal to FH. This time we know the whole length over here is 36, and we know that FG is equal to 21, but we don't know what GH is. So we write all those in. We subtract 21 from both sides. Those cancel. GH is equal to, put a 5 there, 1 there, 15. 15 is our length. All right. It says to plot all of these points, and we want to determine if JK and LM are congruent. Well, the nice thing about these lines is they are horizontal and vertical lines, so we can go about this one of two ways. We can do the old counting method, or we can go this is 1, 2, 3, 4, 5, and we can go this is 1, 2, 3, 4, 5, and so therefore if we show our work, and I would want you to show your work by going 1, 2, 3, 4, 5. So then you could say JK equals 5, and you can go 1, 2, 3, 4, 5, and therefore, oops, sorry, LM is equal to 5. So we could say JK, again, remember with the bar above it, is congruent to LM. The other way we could go about it, if you notice with horizontal lines, the y-coordinates are the same, so we could say JK is equal to the absolute value of the numbers that are not the same, so we would say -3 minus 2, and hopefully you can see that's the absolute value of -5, which is 5, and LM, you notice here with the vertical line, the x-coordinates are the same, so we take these two, and we say the absolute value of 3 minus a -2. 3 minus a -2 is the same as 3 plus 2, which again would give us 5. Here's another one. We should be old hat at this by now. We know VW plus WX is equal to VX. We know that VX is equal to 144. We know that VW is equal to 37, and here's WX. We're going to subtract 37 from both sides. I'm going to do some mental math here. Cross that out and put a 3. So that's 14 gives me 7. 3 minus 3 is 0. So my answer is 107. Okay, for this last one, I'm going to pull up an actual graph so that we can graph them. I've got the points written down, so I'll just plot them on a coordinate plane. Like so. I'm going to close this. The points here are A, which is at -2, 4. So there would be my A. B is at 3, 4. And we're going to connect these two. Here we go, connect the dots. Then we're going to do C, which is at 0, 2, so 0 on the X, 2 on the Y. There's my C. And D is at 0, negative 2. And I'm going to use the counting method to solve this one because that's really the easiest way to do it. And I would expect you to do that as well. If I look at this one, I've got 1, 2, 3, 4, 5. So that means that AB is equal to 5. Make sure you show that work if you use this method. And here we have 1, 2, 3, 4. So CD is equal to 4. So we can say AB is not congruent to CD. Okay? So there's that one. I think we're done now. Again, remember, check over your notes if you need to go back and look at everything. Look at the classwork for tomorrow. Ask questions. Okay? Thanks much.